Hello, hi. Welcome to this term paper presentation video about application of interpretable machine learning models for predicting malaria. Author Rajab Solimo, registration number, and affiliate of Makerere University. Now, to introduce the study here, look at the healthcare facing so many critical issues here, struggling with the traditional methods on how to identify a particular disease basing on so much of the hearsays that actually comes with a lot of shortcomings. In this case, we're looking at inaccurate diagnosis and then perhaps leading to a wrong treatment. Now, severe malaria, as the focus here, is one disease that is causing daily disease across the entire globe. The imminent problem that has been faced is to zero down malaria, which is challenging so many individuals and organizations across the entire globe. Now, utilizing the emergence of machine learning to help in all the fields, particularly in this case the medical field, has been welcome. And looking at utilization of this, previously the medical field has utilized the linear models to actually predict or to use for prediction, and these linear models lack the interpretability. Now, with the growth and emergence of the modern interpretable machine learning models, as per now, the medical field can slightly achieve better and greater predictive accuracy. These models possess the ability to, or the capacity to explain even the non-linear patterns of the disease. The adoption of the AI application in healthcare has faced lots of challenges and critics because of the lack of interpretability. So sectors such as epidemiology are looking forward to identifying important features out of these models that can actually help them lead the general public of the public health in its policy of zeroing down the disease called malaria. To mitigate this challenge, there is need for explainable machine learning. So, looking at the background and motivation here, correct diagnosis of malaria using the modern technologies has sparked a lot of discussions in the medical sector. The malaria parasite is a disease that can be treatable. That's one motivation. It is so much treatable. But now the problem is it can be fatal when it is not classified. These symptoms of malaria show up within 240 to about 360 hours after an individual is bitten by what? By an infected mosquito. Not detecting these cases within these hours may actually manifest or go into a complex situation, which is not easy to be treated. The right treatment can be achieved when the results shows the right infection, but with gamble diagnosis, no, there can be mismanagement of this disease, and yes, the patients will suffer from gradual illnesses. With machine learning algorithms that have got various levels of effectiveness, understanding of epidemiological data, and providing classifications that can make sense based on the relationships of the variables extracted from the target person or the target object. Yes, it is now trying to take where the medical field is trying to embrace this. The current need and utilization of the modern machine learning models, call them the explainable artificial intelligence, to proxenate and interpret the future based on the previous and new opinions without incorporating presumptions, has boosted actually the ability in this medical field to adopt what? To adopt this. So we look this paper focuses on applying or utilizing this interpretable machine learning to mitigate the crucial challenge of severe malaria. The problem statement here, there is need for automated machine learning prediction tools to bring out intricate patterns from features and explainability of the models to assist the medical professionals to come up with what? Better decisions on how to deal with the illnesses and actually have the medical sector what? Move forward. So exploratory modern interpretable machine learning methods to perform greater accuracy with explainability occurrences of malaria, severe malaria in this case, given the signs and symptoms and outcomes from the laboratory tests, is thought to be an achievable thing in this. Some of the related works that have been undertaken, one by Moyes, Shearer, and Huang in Asia. This one employed the logical technique and adaptive regression model to spot the saturation of monkeypox virus and Plasmodium knowlesi parasites. These people looked at the connection between these species and the environmental elements, like the forest cover that harbors this. So when a forest, in this case, which is harboring this, is disrupted, then these mosquitoes are drawn closer to the humans, and hence, yes, stopping and eliminating this requires something which is so another study utilized the time series models with the medical data to approximate the amount of malaria brought by Plasmodium vivax in China, which is sorry, in India, which is specifically Chennai. It used statistical models for analysis. The study findings revealed that these models suited very rightly to the medical data and gave important prognosis of the malaria occurrences. Another study let's utilize data of about 6 years to anticipate malaria in cases collected in medical centers from India. Utilize the gradient boost, which deemed to have been very reliable indicator for the scenarios in this case of the study. Other studies that have been taken by Cha and the group, which proposed the deep learning model and several other techniques to predict 3 separate contagious infections in South Korea. Now, the contribution of the summary of paper contributions here is looking at examining or using various machine learning algorithms in order to choose which one is the most effective one for classification of binary data, exploring the modern explainable AI models for explainability in prediction of diseases, trying to eliminate the challenges faced by imbalanced data in most studies, and other factors contributing to inaccurate prognosis. And we try this paper tries to contribute to the zeroing down of malaria cases through providing in the methodology here. It shows that this paper fully relied on machine learning to answer problems of classification, and it utilized the random forest, the linear regression, the support vector, decision tree, and k-nearest models for its prognosis. XGBoost actually be fitted in performance and speed of execution. The XGBoost utilized the careful cross-validation strategy to build a robust model in this case. Incorporating or bringing in the explainable AIs, sharp interpretable model in this case is brought in to perform the approximation based on these other models that have been used above here. This project or this paper actually consumed a data set from 2,207 participants, which 978 were found with no malaria, 526 were found with severe malaria, and 703 with common malaria. The original training data set was used for both training and validation, which was first divided into two, 80% for building and 20% for validation. Data cleaning and normalization was achieved by performing the following: obtaining of the data set, which is the malaria data set in this case, performing the cleaning, pre-processing, standardization of data, and then implementation using the model. So sorry about that that skip of the slide part. So the methodology framework here is about we first obtain the database, the data set here, After obtaining this data set, we have to, there's an understanding. You need to understand what this data set possesses, which attributes, which other features does it possess. Is it a clean data? Is it so forth? If not, though, then there is data processing that has to happen here. Within this data processing, we are trying to clean out to get a better data set that can perform best for us. Now, in this point here, we are trying to say, all right, now let's handle the missing values. Let's clear out that. Let's handle the outliers. Let's encode, perform some encoding. Let's normalize this data, and perhaps we scale this data. Now, trying to understand the outliers. What are these outliers in this case? Maybe you're trying to bring in something. Outliers are basically values that look to be different from other values within the data set. And what are the reasons of the outliers? Sometimes these are errors made during data entry that can bring out about the outliers, and perhaps others are natural occurrences in that case. Okay, so what do these outliers bring about if they are not handled? They can actually bring problems during model fitting. Then the encoding. This is about transforming the categorical values of data into the numerical ones. All right. The normalization that is performed here, yes, this one is now and scaling is about changing values from the numerical columns to the same scale that can be well understood by the models. So after performing this other pre-processing, there is splitting of data, dividing of data to get what is for training purposes and to get what is for testing purposes or validation purposes. After performing the splitting, there is a post-processing of the data, which is about looking at the feature selection, feature extraction, handling of data imbalances in this case. All right. Now, future selection is about what? This is we're trying to reduce the input variables or getting rid of the noise data in this particular case to get what is so relevant to us. And then with the extraction or feature extraction, this is now we try to transform the raw data set into some numerical features, but without altering or changing any other thing or any other data set, or without alternating or affecting the original data set. So after performing the processing, we have to fit this data set into the models. These are the models that are fitted. After the models fitted, there is employment of the explainable AI models. Now in this case, in here we chose, okay, Sharp is brought in as an explainable model here. So what is going to be the purpose, or why do we need Sharp here? Sharp, explainable AI in this case is about just trying to make our system here pull out some intelligence to the people who are going to be consuming it, by giving lots of explanations. If this is happening, if this is not happening, or if this is right, or if this is okay. Okay, so that is the purpose of the explainable AI here. After that, we are going to have the evaluation standards in this case, where we are now going to look at the accuracy, the so-called the precision recall, and F1. After that, we have to achieve our output in this case. What is our output? Our output is about now looking at, okay, does the system, or has the system actually brought in the explanation that the humans can interpret? An example is, can I understand this, or I understand why this has happened, or this has been happening? Okay, so that is about the explainable AI in this case, and this is in general about what the methodology. Looking at the expected results and discussions, yes, here it is, the future importance. We are trying to focus on about three attributes here: the platelet count, the mean copy HB, and the neutrophils count. These are the ones that can give us better prognosis about the severe malaria in the future, with platelet being one of the ones that has given us the highest of 22.0 in this case. Uh, uh, Understanding that the sharp here, the explainable AI, this one has given us a base value of 6.08, which is so high that, yeah, and sorry, the base value of negative 0.494. Okay, and these red values are the ones that are going to be reducing, and then these other blue ones are the ones which are going to be increasing. So the blue ones, the mean platelet, and then the neutrophils are the ones that are the model is going to be focusing on to provide better prognosis. Here is an multi-class rock curve, and the blue line here is for the non-malaria infections. The orange line is about the severe, is for the severe, and then the green line is for the uncomplicated malaria. So we can look at versing the rest, versing rest. So the non-malaria infections actually provided a 0.66 with the severe malaria, but the uncomplicated here is of 0.44, which means it's not so much of value. But these are the observations or the evaluations of the models presented in this table here in percentage form. Okay, digging into the explanation here, the model actually adopted 6 models, which these 6 models are the ones explained or looked onto the above table that we looked at in the previous slide. The approach which is taken in this study is to identify the attributes from the clinical examination as the top classifiers to determine which ones belong to the uncomplicated malaria and which ones do belong to the non-malaria infections. Here in this model, logistic regression and KNN obtain above 70% of accuracy, prediction accuracy, which they are the best performing in this case out of the 5 models before the the XGBoost classifier. Other models performed very bad, as it's always assumed that whichever model that provides an accuracy of 70 and above, that one has performed better. So these other ones perform less. Reasons could be some of these models do work with small amounts of data, others work with big amounts of data. That's why they were not able to provide best or better results. Now, extreme gradient boosting showed to perform better in predictions, which is about 83% of accuracy, precision recall, and F1. This one has showed that, yeah, maybe to achieve this XGBoost tried correcting some of the errors within the prediction, within the models, and then this gave some greater or more prediction accuracies. Now, if such things are utilized, then early prognostication of malaria can no longer be a challenge, because there can be greater accuracy and greater accuracy about it. Somebody can actually identify, oh no, this one is now going at this, and it can help, or this is going to help actually policymakers or governments to come up with early warning systems of how this complicated malaria can be manifested to such level. Right now, the explainable AI models that have been employed in this study, how do we evaluate them and how do we measure them? A very subjective evaluation of the usefulness and clarity of an explanation can be used to gauge, user satisfaction. Is the user satisfied? Has the user actually appreciated this? If yes, okay, fine, then that one is good, which is one of the several measures that are so subjective from the perspective of the user, and these models are made for the user, and this is what has been lacking previously. Does the explanation improve the user's decision making? Maybe a more subjective way to gauge an explanation's usefulness. So how to accurately and consistently measure the impact of this explanation remains still an outstanding research question. But at the assessment and quantification for explainable AI systems will involve assessing the frameworks, coming up with different reasonings, and then the mutual understanding and rational thinking and augmentation of what? The system. That is what is going to be used for evaluating and measuring what? This. To conclude this work, we find out that classifying and predicting of malaria infections can be realistic with application of the ML techniques. Integrating the explainable AI models brings out explainability that has been lacking for supporting the healthcare system decisions. So machine learning classifiers effectiveness is thought to be impacted a lot by the sparse and faulty data that are used. In the future, the study looks at or aims to utilize the real world clinical data for accurate precisions so as to provide some better treatments. So what's what? A target disease. Incorporating other machine learning techniques like now extending the explainable AI in deep neural network that can teach computers to perform naturally and learn by example could be another what? Future to look at. These are the references that were consumed in this study. I thank you for your time.